Hello children, welcome to Math Park. Our today's topic is coordinate geometry and we are going to understand the concept and solve exercise 26A entire exercise. So children, after going through this video, if you like it, please share with your friends, and if you are new to the channel, please subscribe. So let's understand the concept. Who is this Cartesian? This was a mathematician. When he was sleeping and he was looking at the ceiling up there, he found the spider moving, and the spider was moving in a definite pattern, and from that he discovered how to locate the points. And this system was coordinate system was discovered by Cartesian, Rene Cartesius. That is why it is called Cartesian coordinate system. Now this is x-axis and y-axis, and we have four quadrants over here. So this is your first quadrant. In the first quadrant, you can see that x-axis, when you go on right, it is positive, left it is negative, up positive, down negative. So in the first quadrant, both the x-axis and y-axis, both the points are positive. So this is plus and plus. Then we go anti-clockwise. This is the second quadrant. So x coordinate is always written first. So x is negative and y is positive. This is the second quadrant. Then the third quadrant, we have both the points negative. And in the fourth quadrant, we have negative, and then x coordinate is positive and the y coordinate is negative. So positive, negative. So this is how we have four quadrants. Okay, so these are the four quadrants: first, second, third, and fourth. Right? Now let us start solving exercise. While solving exercises, again, I'll be explaining the concepts when it comes over there. For each equation given below, name the dependent and independent variable. So let's understand what is dependent and independent variable. Y is equal to 4 by 3x minus 7. Now here y is the subject. So whichever is the subject, that is our dependent variable. So this is dependent, and here x is independent. This is dependent and x is independent. So whichever is the subject meaning which is equal to, y is equal to, y is on left hand side and rest all thing is on other side, then y is dependent. Now here x is dependent and y is independent. Again here x is dependent and y is independent variable. Here y is dependent and x is independent variable. Easy that? So whichever is the subject, that is the dependent, and other is independent. Okay. Question number 2, plot the following points on the same graph paper. So let us understand. So let us say this point as A. This is your B. This is your C. This is D. E, let us this be F, G, H, and I. So we have to draw x-axis and y-axis. I have taken ready here. So this is your x-axis and this is your y-axis. You have to draw x-axis and y-axis, and then you have to put on right side it is positive, up it is positive, left it goes negative, down it goes negative. So point A87. So here this is x coordinate and this is y coordinate. Now x coordinate is also called abscissa. It is also called abscissa, and y coordinate is also called ordinate, and they both together make the coordinate system. So when it is x, so we look for x on x-axis, 8 on x-axis, and 7 on y-axis. So 8 and this is 7. So this is your point A, which is 8, 7. Then B3, 6. So B3 is again positive on x-axis and 6 is positive. So 3, 6. So this is your point B, which is 3, 6. C0, 4. So x is 0 and y is 4. So this is your point C, which is 0, 4. D 0 minus 4. So x is 0, y is minus 4. So this is your point D, which is 0, minus 4. Your E is 3, minus 2. So which is going to lie in the fourth quadrant, 3 and minus 2. So this is your E, which is 3 and minus 2. Then we have F, which is minus 2 and 5. So x coordinate is minus 2 and y is positive, which is 5. So this is your F, which is minus 2, 5. Now G is minus 3, 0. So x is minus 3 and y is 0. So this is your point, which is G, that is minus 3, 0. Now H is 5, 0. So 5 is on x-axis. This is 5 on x-axis and 0 on y-axis. So this is your point, which is H, that is 5, 0. And the last point I, it is -4, -3. So that is going to lie in the third quadrant, -4 on x-axis and -3 on y-axis. So this is your I, which is -4, -3. So understood how to plot the points? When numbers are written in a specific order, we call it as an ordered pair. So here, this is called the first component, and then it is the second component. So this is your first component, this is your first component, and this is your second component. Now, if the two ordered pairs are equal, you can see the equality sign here, then the corresponding components are equal. And that is what we know, that if two ordered pairs are equal, we know that the two ordered pairs are equal, then their components are equal. That is, you get x minus 1 is equal to 4. So x is equal to 4 plus 1, which is 5. Same way, we have y plus 3 is equal to 4. These two are equal. So this is how y is equal to 4 minus 3, which is 1. So this is how you get x is equal to 5 and y is equal to 1. The second part of this again, we have 3x plus 1 is equal to 9. So solving this, you get 3x is equal to 9 minus 1. So 3x is equal to 8. So x is equal to 8 by 3. And if you have 2y minus 7 is equal to minus 9. So 2y is equal to minus 9 plus 7. 2y is equal to minus 2. So y is equal to minus 2 by 2, which is minus 1. So this is how you have x is equal to 8 by 3 and y is equal to minus 1. The third part of this, 5x minus 3y, y minus 3x is equal to 4, minus 4. So we have 5x minus 3y is equal to 4. And this is one of the equations that you get. And you have y minus 3x is equal to minus 4. So you get simultaneous equations here. So this can be written as minus 3x plus y is equal to minus 4. So let us solve this equation. So minus 3x plus y is equal to minus 4. Solving these simultaneous equations, see each chapter is related on each other. So we need, so here to make the y coefficient same, we will be multiplying this equation by 3. So we write the first equation as it is, 5x minus 3y is equal to 4. And 3 times minus 3 is minus 9x plus 3y is equal to minus 12. Here y gets eliminated. And you have 5 minus 9x is minus 4x is equal to 8 minus 12 is 4 minus 12 is minus 8. So this is how you get x is equal to, minus 8 by minus 4, which is 2. Now this can be substituted in any of the equations. This can be substituted in any of the equations to get the value of y. So substituting x is equal to 2 in equation number, let's say, this equation number, equation number 2. This was our equation 1, this is equation 2. So y minus 3x, that is 3 times 2 is equal to minus 4. So you get y minus 6 is equal to minus 4. So y is equal to minus 4 plus 6, which is equal to 2. So this is how you get x is equal to 2 and y is equal to 2 is the solution for this equation. Use the graph given alongside to find the coordinates of points satisfying the given condition. Now, abscissa is 2, that is x coordinate is 2. So, and we have to find the x coordinate is 2. So abscissa is 2, this is the point A. So point A is abscissa is 2. So the coordinates of A are 2, minus 2. So where abscissa is 2, we get point A. A is a point which is where abscissa is 2. Now, abscissa 2 is another point which is D. D is a point and the coordinates of point D are 2, minus 4. So, A and D are the 2 points where the abscissa is 2. Then, is there anywhere 2? Yeah, these are the 2 points. The next, the ordinate is 0. Ordinate is 0 means y coordinate is 0. So, y coordinate is 0. Then the point is going to lie on x-axis and that is point B. So, where the coordinates of point B are 5, 0. Coordinate of point B are 5, 0. So, B 5, 0 is a point where the ordinate is 0. Ordinate is the y coordinate. The ordinate is 3. Ordinate is 3 means y coordinate is 3. So, look at 3 on y axis. So this is 3. So it is C is the point where the coordinates are -4, 3. So one of the point is C where the coordinates are -4, 3. Ordinate is 3. And again on in the first quadrant, the point E where the coordinates are 6, 3. So point C and E. The coordinates of E are 6, 3, where the ordinate is 3. These are the 2 points C and E. The ordinate is -4. So look for the -4 on y-axis where the ordinate is -4. Ordinate is -4 is the point D where the coordinates are 2, -4. This is the only point where the ordinate is -4, only point, that is point D. Then the abscissa is 5, that is x coordinate is 5. So x coordinate is 5 is point B where the coordinates are 5, 0. This is the point. Abscissa 5. Now abscissa 5 is again H where the coordinates of H are 5 and Y are also 5. So abscissa and ordinate both are 5 and 5. So H is one of the point where abscissa is 5. So coordinates are 5, 5. And again, phi ordinate abscissa phi is G again. So coordinates of G are phi, comma, this is your -3, phi, comma, -3. So abscissa phi, there is another point G where the coordinates are phi, comma, -3. Any other point? Phi from here, B we have done, H we have written, G. That's it. These are the 3 points. The abscissa is equal to the ordinate. So abscissa and ordinate both equal. This is one of the point H where abscissa and ordinate are equal, phi, phi. Is there another point where abscissa and ordinate are equal? Abscissa and ordinate equal. So if abscissa and ordinate are equal, either the point should lie in the first quadrant because both positive, or it should lie in the third quadrant where both negative. So it is 2, comma, this is point A. No, it is 2 and 2. Yes, point A again, 2, 2. So point A, which is the both coordinates are same. So A, 2, 2. Yes, where abscissa and ordinates are same. This is the point. Then I is 4, 4. So I, it is 4, 4. So I is another point where abscissa is equal to ordinate. So I 4, 4 is another point where abscissa and ordinate are equal. H we have written 5, 5. A we have written 2, 2. I we have written. That's it. These are the 3 points. In the third quadrant, we don't have any. This is the answer. The ordinate is half of abscissa. The ordinate is half of abscissa. That means y is x upon 2. So y is equal to x upon 2, half of that. So the ordinate is half of abscissa. This is point E where x coordinate is 6 and y coordinate is 3, which is half of 6. So the point is E 6, 3. So this is how we have done with question number 4. Moving to question number 5, straight true or false. The ordinate of a point A is on its x coordinate. The ordinate of a point A. The ordinate of a point is its x coordinate. So it is false because ordinate is called an y coordinate. This is y coordinate. The origin is in the first quadrant. This is also false. Origin is not in the quadrant. It is exactly on x-axis and y-axis. There is a point where x-axis and y-axis meet. The y-axis is a vertical number line. Yes, it is the vertical. So this is true. Y-axis is the vertical number line. Every point is located in one of the 4 quadrants. Every point is located in the one of the 4 quadrants is false statement because sometimes the point is also located on the axis. So this is the false statement. If the ordinate of a point is equal to its abscissa, the point lies either in the first quadrant or second quadrant. So this is again false because it will lie either in the first or in the third, because here we have both positive. So both, if they are equal, and both negative. So this will lie either in the first or in the third. So this is the false statement. The origin 0, 0 lies on the x-axis. The origin 0, 0 lies on the x-axis is the true statement. So it also lies on the x-axis and also lies on the y-axis. So if it is lying x-axis, yes, we can say it is a true. Then the point A, B lies on y-axis if B is equal to 0. if b is equal to 0, that means y coordinate is 0. So the point A, B lies on y-axis if B is 0. So if B, that means y coordinate will be 0, the point is going to lie on x-axis. So therefore, this is a false statement. Clear? In each of the following, find the coordinates of the point whose abscissa is the solution of the first equation and the ordinate is the solution of the second equation. So the first equation, you get abscissa. So let us solve this equation. So you get minus 2x is equal to 7. 3 goes here, minus 3. So you get minus 2x is equal to 4. So x is equal to 4 upon minus 2, which is minus 2. Let us solve another equation. So we have 2y plus 1. This is another equation. So we get 2y minus 2 to the 4 plus 1, 5. 5 by 2. So this is 5 by 2 y comes here. It becomes plus 5 by 2 y is equal to 10 plus 1 goes there, becomes minus 1. So let us take LCM. 2 2s are 4y plus 5y upon 2 is equal to 9. So we get 4y plus 5y is equal to 9 times 2, which is 18. So 4 plus 5, it is 9y is equal to 18. So y is equal to 18 upon 9, which is equal to 2. So find the coordinates of the point. So the coordinates of the point whose abscissa is the solution of the first is minus 2, 2. So this is the answer for the first one, minus 2, 2. Let us solve the second one. In the second one, we have 2a upon 3 minus 1 is equal to a by 2. So the solution of the first one is the abscissa. Let us solve. Let us take the terms with a on another side. So we have 2a upon 3 minus a by 2 is equal to minus 1 goes here, becomes plus 1. LCM of 3 and 2 is 6. So 2 2s are 4a minus 3a is equal to 1. So we get 4a minus 3a is equal to 6. 4 minus 3 is 1. A is equal to 6. So we got a is equal to 6. So which is x is equal to 6 because the solution of the first one is abscissa. Solving the second part, 15. So let us cross multiply here. Let me take the color different so that you'll be able to see. So 3 times 15 minus 4b is equal to 7 times 2b minus 1. 3 times 15 is 45. Minus 3 times 4 is 12b is equal to 7 2s are 14b. 7 times 1 is minus 7. Bring the terms with b on one side. So minus 12b, 14b comes here, becomes minus 14b is equal to minus 7 minus 45. 12 minus 12 minus 14, 4 plus 2, 6. This is minus 26b is equal to 7 plus 5, 12, carry 1. It is minus 52. So b is equal to minus 52 upon minus 26, which is b is equal to 2. So this is how you get x is equal to 6 and b is nothing but y. So y is equal to 2. Third part of question number 6. So 5x minus 5 in bracket x. Let us solve the first part, first equation. So we get 5x, 5 minus 5 minus into this 1 into 5 is minus 5, minus into minus is plus x is equal to half in bracket 3 minus x. Let us keep it as it is. So 5 plus 1, this is 6x and minus 5 is equal to half in bracket 3 minus x. Let us shift this 2 over here. 2 in bracket 6x minus 5 is equal to 3 minus x. 2 6 are 12x minus 2 5 are 10 is equal to 3 minus x. X comes here, 12x plus x is equal to 3 plus 10. So you get 13x is equal to 13. So x is equal to 13 by 13, which is 1. The second part, second equation of this to get the ordinate, So we have 4 minus 3y. So let us bring this 3 here first of all. So 3 in bracket 4 minus 3y is equal to 4 plus y. So 3 4s are 12 minus 3 3s are 9y is equal to 4 plus y. Bring the terms with y minus 9y. Y comes here minus y is equal to 4. 12 goes here minus 12. Minus 9 minus 1 is minus 10y is equal to 4 minus 12 is minus 8. So y is equal to minus 8 by minus 10. dividing by 2, 2 4s and 2 5s. So we get y is equal to 4 by 5. So we get y is equal to 4 by 5. So thus we have x is equal to 1 and y is equal to 4 by 5. These are the coordinates of the question number 3. Moving to question number 7. In each of the following, the coordinates of the three vertices of a rectangle ABCD are given. By plotting the given points, find in each case the coordinates of the fourth vertex. So let us do the first one. So drawing x-axis and y-axis. So here I have taken it ready. So let us draw x-axis and y-axis. So this is your x-axis and this is your y-axis. So let us plot these points A 2 0. So A x coordinate is 2 and y is 0. So it is going to lie over here. So this is your point A, which is 2 0. Then B 8 0. So B is 8 and y coordinate is 0. So this is your B 8 0 is this point. Then C 8 4. So 8 4. So C 8 4. C 8 4 is the third vertex. And this is a rectangle. So we know that in a rectangle, opposite sides are equal. So we have to find the fourth vertex. So the fourth vertex is going to be D and the fourth vertex D is 2, 4. So the fourth vertex is 2, 4. So this is how we get a rectangle ABCD where we have found the fourth vertex and the fourth vertex of this rectangle was D2, 4. Now we will be doing the next one 4, 2, B4, 4, 2, B minus 2, 2 and 4, 2. Let us plot these points and we'll find the coordinate C now. So let us take some other color for drawing this because we are doing on the same grid. So A4, 2, A4, 2. So 4, 2, this is your point A now. A4, 2. Then you have B minus 2, 2. So x-axis minus 2. So this is B minus 2, 2. And you have D4 minus 2. So D4 minus 2. So this is your D4 minus 2. And then you are asked to find the fourth vertex. The third one, A minus 4 minus 6. So A minus 4 minus 6. Minus 4 on x-axis and minus 6. So it is going to go on third quadrant. This is your A, which is minus 4 minus 6. Then C 6 0. So C 6 0. X is 6 and Y is 0. So 6 0. This is your C. So C 6 0 is this point. And D minus 4 0. So D is minus 4 0. So D is x is minus 4 and y is 0. So this is your D minus 4 0. And you are asked to find the fourth vertex. So since the opposite sides of rectangle are equal, the fourth vertex D is going to be 6 and minus 6. So this is how this is our rectangle, the third one. So this is ABCD is the rectangle where we found the fourth vertex B, which was 6 minus 6. So B6 minus 6 was the fourth vertex. Let us do the next one also in the same. Let us choose some other color so that it doesn't look clumsy. So it is B10, 4. So B10, 4. B10. So this is your 10. So 10, 4. This is your point B, which is 10, 4. Then C0, 4. So x coordinate 0 and y 4. So it is going to lie on y axis. So this is C0, 4. This is the point. Then D0 minus 2. So x coordinate 0 and y minus 2. So this is your point D, which is 0 minus 2. And then the fourth vertex is going to lie over here, which is ABC, and the vertex is 10 minus 2. So this is the fourth vertex C, which is 10 minus 2. And this is our fourth question done. Found out the fourth vertex of the rectangle ABCD. Use the scale since I am not able to do here. I'm doing with the hand. So we did with question number 7. Let's move on to question number 8. A minus 2, 2, B 8, 2, C 4 minus 4 are the vertices of a parallelogram ABCD. By plotting the given points on a graph paper, find the coordinates of the fourth vertex D. Also from the same graph, state the coordinates of the midpoints of side AB and CD. So let us draw plot the given point. So A minus 2, 2. So A minus 2, 2. So this is your point A, which is minus 2, 2. Then B 8, 2. 8, 2. This is B 8, 2 is the another point, second point. Then C 4 minus 4. 4 minus 4. 4 minus 4 is C. So C 4 minus 4 is the next point. Units. And this is 4 and plus 6. So this is going to be the fourth vertex. So 10 units, opposite sides are equal. So the vertex D, the coordinates are minus 6, minus 4. These are the this is the vertex. So let us join and draw the parallelogram. So this is our parallelogram ABCD. And we know that opposite sides of parallelogram are equal. And here is the parallelogram. Now next we are 1, 2, 3, 4 and 5. So this is the midpoint of AB. Let us say the midpoint of AB is say M, and the coordinates of the midpoint of AB are 3, 2. So 3, 2 are the coordinates of the midpoint AB. So AB, that is M, 3, 2 are the coordinates. And CD, the midpoint of CD. Midpoint of CD, again, this is total 6 distance. So this is the midpoint. Total unit is 5. The midpoint, let us say N, and the coordinates of the midpoint of CD are, this is minus 1, minus 4. Minus 1, minus 4. So midpoint of CD is N, which is minus 1, minus 4. Thus, we have done with question number 8. Moving to question number 9. A minus 2, 4, C 4, 10, and B minus 2, 10 are the vertices of square ABCD. Use the graphical method to find the coordinates of the fourth vertex B. So let us do with the first part. A minus 2, 4. So A minus 2, 4, minus 2x, and on y-axis 4. So this is your point A, which is minus 2, 4. Then next point is C 4, 10. So 4 and 10 on y. So this is your C 4, comma 10. And D minus 2, 10. So x coordinate minus 2 and y coordinate 10. So this is your D minus 2, 10. And this is a square. So square, so all the sides of the square are equal. So the fourth vertex B is going to be 4, comma 4. So this is the fourth vertex. So this, our square is ready. Our square is ready. ABCD is a square. Now let us see further what is to be done. Then also find, we have found the fourth vertex B, which is 4, 4. Also find the coordinates of the midpoint of BC. Now midpoint of BC, look at this. This is total distances 1, 2, 3, 4, 5, 6 units. So the midpoint of BC, let us say M is the midpoint of BC, and the coordinate of the midpoint of BC are 4, 7. So 4, 7 are the coordinates of midpoint of BC. Let us say it is M4, comma 7 is the answer for this. The coordinates of the midpoint of CD. Midpoint of CD is this point. Let us say N, and the coordinates of N are 1, 10, 1, comma 10. So the midpoint of CD is N, 1, comma 10. These are the coordinates. The coordinates of the point of intersection of the diagonals of a square ABCD. The coordinates of the point of intersection of the diagonals of a square. Look at this distance diagonally, and this is the midpoint of the diagonal. And we know that the diagonals of a square are equal and they bisect at right angles. So the midpoint or the point of intersection of the diagonals of a square, let us say it is say P, and the coordinates are 1, comma 7. The coordinates of the midpoint of the diagonals or the intersection of the diagonals is 1, comma 7. We have named it as P. So thus we have done with question number 9. Moving to question number 10. By plotting the following points on the same graph paper, check whether they are collinear or not. So let us plot the first one we are doing now. 3, 5. So let us name it as A. Let us name it as B, and let us name this as C. So A 3, 5. So A 3, 5. This is your A 3, 5. And then B11, so B11, this is your B11, and C 0, minus 1, so C is 0, minus 1, 0, minus 1, this is your point C, 0, minus 1. So what do you find here? Are they collinear? So if you are drawing a line, does that line pass through these 3 points? Does this line pass through these 3 points? And we can see that these 3 points are collinear. That is, they lie on the same line. So we can say that these points are A, B, C, are are collinear. They are collinear. That means they are lying on a same line. Now let us look for the second part. In the second part, -2, -1, let us name it as P, Q, and R. So P -2, -1, P -2, -1, this is your point P, which is -2, -1. Then Q -1, -4, -1, -4, this is your Q, Q which is -1, -4, and then R which is -4, 1. So R is -4, 1. This is the point R which is -4, 1. And we can see that these points do not lie on a same line. They don't lie on a same line. So we say that PQR are non-collinear. Non-collinear. They do not lie on a same line. Moving to question number 11, plot the points A, 5, -7. From the point A, draw AM, let us perpendicular to X axis, Y axis. So this is your X axis and this is your Y axis. And let us plot the point A, 5, -7, A, 5, -7. So this is your point A, which is 5, -7. And they say from a point A, draw AM perpendicular to X-axis. So AM perpendicular to X-axis is this one. This is your AM, which is perpendicular to X-axis. So this is your line AM, which is perpendicular to X-axis. And the coordinates of the point, or write the coordinates of point M. So point M and N. So coordinates of point M are 5, 0. So M, 5, 0 are the coordinates of the line which is perpendicular to x-axis. Next, they are asking draw AM perpendicular to x-axis and AN perpendicular to y-axis. So perpendicular to y-axis from A, it is going to go like this. This is your AN, which is perpendicular to y-axis. At point N, it is being perpendicular. This is 90 degree. And coordinates of N are 0, -7. So N coordinates are 0, -7. Easy. Question number 12. In the square ABCD, A 3, 4, B -2, 4 and C -2, -1. By plotting these points on a graph paper, find the coordinates of the vertex and find the area. So let us plot A 3, 4, A 3, 4. This is your A 3, 4. B -2, 4. B is -2, 4. So this is your B -2, 4. C -2, -1. -2, -1. This is your C, which is -2, -1. And they are asking us to find the fourth vertex. So since it is a square, the fourth vertex is going to be this. So this is your square ABCD. And then you are asked to find, sorry, this is the point. This is the point, fourth vertex. And then you are asked to find the area of the square. Now, area for square is side square. This is 2 plus 3, 5 units. This is 4 plus 1, 5 units. If you count the number of squares, they are going to be 25. So we have the fourth vertex. Let us first write. The fourth vertex is 3, -1. So the fourth vertex D is 3, -1. And area of square ABCD. Area of a square ABCD, we know that the side is 5 units. It is 5 square, which is 25 square units. 25 square units is the area of this square. And also with counting this number of squares also you get the same 1, 2, 3, 4, 5. So if you count the number of squares, you are going to get 25 square. This is how we found the area of the square. The last question of this exercise, in rectangle OABC, point point O is the origin. OA is equal to 10 units. So let us draw the graph again here. So in rectangle OABC, O is the origin. So this is point O, with the coordinates of O are 0, 0. OA is 10 units along x-axis. So OA, this is your A, which is 10 units along x-axis. And AB is 8 units. AB is 8 units. So this is your B is going to be here, which is 8 units. So coordinates of B are 10, 8. So AB is 8 units. The distance, this distance Y, it is 8 units. Find the coordinates. And find the coordinates of the vertices of A, B, and C. So A, Coordinates of A are 10, 0, coordinates of B are 10, 8, and coordinates of the next vertex OABC, coordinates of the next vertex C are going to be 8, 0, 8. X axis it is 0 and y axis it is 8. So this is how the rectangle OABC, and we found the required coordinates. We have done with this exercise, children, and if you like it and if you feel it is helpful, I am coming up with the next exercises soon. Please see that you share with your friends, and if you are new to the channel, please subscribe. Thank you for watching. Have a good day.